Hello, in this video we're going to talk about chemical bonds. Our objective is to be able to predict whether two atoms are likely to form a covalent, polar covalent, or ionic bond based on their pull for valence electrons. First of all, the reason atoms bond in the first place is to become more stable. And what that means is that they're going to be more stable when they have a full valence shell, when that outer level of electrons around the atom is full. You might have heard of the octet rule before. Octet stands for 8. In most cases, a valence shell is full when it has 8 electrons. One important exception is that the first energy level is full when it has 2 electrons. So helium, for example, would be stable with only 2. It's important to know the pattern of valence electrons on the periodic table. So look closely and see what pattern you can find as you go across the periodic table. Hopefully you notice that every atom in the first row has 1 valence electron. Every atom in the second column going down has 2. If you skip the transition metals and go to column 13, they all have 3, 14, 4, 15, 5, 16, 6, 17, 7, and 18, 8. And all the atoms in the last row have that full outer energy level and are really stable. Secondly, whether an atom loses or gains electrons to fill that valence shell is going to depend on its attraction for valence electrons and the attraction between the atom that it reacts with. We have a term, electronegativity, that gives us an idea of how strongly atoms will be able to pull new bonding electrons to themselves. And it has a lot to do with what we talked about in the last section of the unit, with how strongly the nucleus has a pull for its valence electrons. So take a second to predict which element below you think would have the highest electronegativity, the highest likelihood of pulling new electrons to itself, and which would have the lowest. Remember that as you go across a row, the attraction for electrons gets stronger because you're getting more protons in the nucleus. And as you go down the periodic table, it gets weaker. So that means that in the top right corner, you're going to have the strongest pull for electrons. Electronegativity is a little bit more specific, though, in that you have to attract new electrons. And so the most electronegative is actually fluorine. Helium is already full. It's not going to gain any more valence electrons. And so fluorine is going to have the highest electronegativity. The lowest electronegativity is going to be in the opposite bottom left-hand corner. So out of the ones shown, sodium has the lowest attraction for new valence electrons. But if you had the full periodic table here, the bottom left element would have the lowest electronegativity. And you can see this on your periodic table. It's helpful to think of atoms when they bond with each other. They're pulling for each other's electrons, kind of like a game of tug of war. And so sometimes if atoms have an equal electronegativity, they're going to kind of share those electrons back and forth evenly between them. But sometimes that pull for electrons is not equal, and so the electrons are not going to spend equal time between both atoms. So we can have what we call a nonpolar covalent bond or a polar covalent bond. If the pull for valence electrons is equal, then as it is between two of the same types of atoms, we get a nonpolar covalent bond, where the electrons that they're sharing to each get 8 are pulled equally between the two atoms. Over here, the pull's not equal. One atom, chlorine, has a much higher electronegativity, a much stronger pull for valence electrons, and the hydrogen has a lower electronegativity, a much weaker pull. And so the electrons spend more time around the chlorine atom than they do around the hydrogen atom. This gives the chlorine end a partial negative charge and the hydrogen end a partial positive charge. And so if you think about the word polar, you might think North Pole and South Pole, you have two opposites. Nonpolar, the ends are the same, so they don't have different poles. polar covalent, you have a positive end and a negative end. You do have different poles of your molecule. Sometimes the differences in the electronegativity are so high that instead of the electrons bouncing back and forth in between, they get completely taken away. This happens if atoms have a really large difference in electronegativity. So this will often happen between a metal on the left-hand side of the periodic table and a non-metal on the right-hand side of the periodic table. And metals don't have very many valence electrons to start with, so they usually lose electrons to get to that full energy level beneath. So chlorine comes close enough that its nucleus literally pulls away the valence electron from sodium. Sodium then has one more proton than electron and forms a positive charge. The chloride atom has one more electron than proton and forms a negative charge. They are now ions, charged atoms. And so because they have opposite charges, they attract to each other, and that is what really forms that bond between the atoms, is just the attraction between the opposite charges. Notice that sodium now has 8 valence electrons in its outer level, and chloride also has 8 valence electrons in its outer shell, and so both atoms are very stable, and that's why they have formed this bond in the first place. So to summarize, the type of bond that two atoms will form depends on their differences in electronegativity. If they have a really similar pull on electrons, then the electrons are going to go back and forth relatively equally. Both of the ends of the bond are going to be the same, and you have a non-polar covalent bond. And just to maybe think about covalent, right? The valence electrons are shared between the two. If the electronegativity difference is a little bit higher, you can get a polar covalent bond where the atom with a stronger pole is going to be partially negative, and the end of the bond with the lower electronegativity is going to be partially positive. So different poles, negative pole, positive pole. And lastly, if the electronegativities are so different, like a metal and a non-metal, the non-metal that has a stronger attraction can completely pull away an electron or multiple electrons from the other atom, and then those oppositely charged ions attract, and we have an ionic bond. So those are the three types of bonds, and how they form between atoms with similar versus different electronegativity.